So we should be live. Let's just double check. Let's just minimize that. And just double check here. I'll open the live stream itself. Bear with me a second. So can you guys hear me? I am a little bit late, so hopefully there is still some people waiting. Yeah, can you hear me? Give us a thumbs up or something if you can hear us, and then we can make a start. Ugh. Oh, there we go. I can see some love hearts flying through the chat. Yes. Okay, perfect. Right. So yeah, so apologies. I am 15 minutes late. If you know anything about me, I am never on time, but I will be for the later on session today. But anyway, just close that as well. Just move it onto this screen, just so I can follow along here. Right. So let's just make a start here. So yes, I'm a little bit late. Apologies again. Right. So before I make a start here, we're going to run through 10 questions in total for this live stream. There's going to be another live stream a little bit later on, kind of like a similar layout. The questions are kind of like a mix in terms of difficulty, a couple of like trickier questions, but for the most part, the questions that I've chosen here are kind of like a broad variety in terms of difficulty, more to kind of appeal to, you know, the majority of students rather than A-star students. You know, so if you're an A-star student, this probably isn't going to be the most useful stream for you. But either way, you know, hopefully there should be some good revision within this stream here. So let's not waste any more time then. So as I've said, we're going to run through 10 questions in total. So question 1 here. So it'll go stats, mechanics, by the way, and we will alternate. So for question 1 here, pretty straightforward question just to get us started then. So we've got Jim here who farms oysters in a particular lake. Now he knows from past experience that 5% of young oysters do not survive to be harvested. So RIP to those oysters. Now, in a random sample of 30 young oysters, the random variable x represents the number that do not survive to be harvested. So for the first mark here then, this is for part A, right? It just says then write down a suitable model for the distribution of x. Now, for A-level maths, there are 2 distributions that you need to be familiar with here. You've got the binomial distribution and also the normal distribution. Now, it's usually pretty obvious which one it will be if we're talking about probabilities such as this here, and then you're given a sample size such as this here, then it's going to be the binomial distribution. If it's going to be the normal distribution, then what we've got there is, you know, mu, and the standard deviation, right? Those are the 2 key parameters there for the normal distribution, or the variance, I should say. So for part A here, again, I'm hoping it's obvious that this is the binomial distribution. So x here is the random variable that we're using. So x will follow a binomial distribution. Use b to represent that, right? And then we've got our 2 parameters here of n and p. So n is your sample size here, which is just given as 30, so in a random sample of 30 young oysters. So n is 30. And then for p here, so we class this as the probability of success. I mean, in this case here, the probability of success is that the oyster dies, basically. So it's a little bit grim, but that's going to be 5% or 0.05, right? So 0.05, just like that, okay? And there we go then. So that's all we need there for part A. So somebody's put, what if you write x and then n 30, 0.05? That's going to be incorrect because that is representing a normal distribution. Obviously, your parameters there are incorrect. You need to use the b here just to represent a binomial distribution, right? So let's just move on to part B here. So for part B then, it just says state an assumption that has been made for the model in part A. So one assumption here is that the survival of each oyster would be independent of the other oysters, right? So it's just one mark. We just need one assumption here, and that would be absolutely fine. So how can I word this here then? I'll say each oyster's survival. Each oyster's survival. Survival is independent of the others. Okay. And there we go. So nice and straightforward there. Just one mark there for part B as well. And now for part C then. So the final part here, it just says find the probability of that. And then we're given two different things here. Now, so we've got two different parts here. So for C part 1, just be very, very careful here. So we want to find the probability that exactly 24 young oysters do survive to be harvested. Now they kind of put this in bold here just to kind of put a bit of emphasis on this. So just be very, very careful. So if 24 do survive, then what we're saying here is that 6 do not survive, right? So this is saying that 6 do not survive. 6 do not survive. Again, RIP. So we're just going to use this model here, right? So X follows a binomial distribution, N is 30, and P is 0.05. Now, for this question here, so C part 1 and C part 2, please just use your calculator. You can do this by hand, but it's just much easier to just use a calculator, right? Now, when you do this on a calculator here, you have a choice of BPD or BCD. So my question to you guys then is, what would this be? Would this be BPD or BCD for C part 1 here? So BPD or BCD. What would you choose here? Someone give us a shout. Someone's put PD. Yes, exactly right. It's going to be BPD because what we're actually looking for here is the probability then that X is equal to 6, right? Because 6 do not survive here. So yeah, so in this case here, we use PD for the second part here because at least here, that would be a cumulative probability, but we'll cross that one when we get to it, right? So just grab your calculator here. It wants a few different things then. So it's going to ask for N here. It's going to ask for P, and it's going to ask for X here. So N here, that's just your sample size, right? So we're given that here. That's just 30. For P then, that's the probability of success here, which we defined as 0.05. So 0.05. And then for X here, that's just whatever we input here, right? So in this case here, X is just simply 6 when my pen decides to work. There we go. And then input those, press enter, and this would give you this probability here, right? So if you do all of that correctly, then what you should get here is 0.0024. So 0.0024 there. Okay, so hopefully, if you're kind of working along here, hopefully you did get the exact same here then for this probability. Okay, give us a shout in the chat if you didn't, and we can try and troubleshoot what we did incorrect. But there we go. So that's C part 1, not B part 1. And then for C part 2 here, as we said before then, this is now a cumulative probability here. So it wants the probability that at least 3 young oysters do not survive to be harvested. So what I'm looking for here then is the probability that X is greater than or equal to 3, right? If we're looking for at least 3 here, then we set it as this probability here, okay? So if we've got a cumulative probability such as this one here, right? And we're saying then, hang on, let me just read the chat. Someone's saying they got a slightly different. I'll double check it in a second. Let me just come back to that in just a moment. Maybe I've done it incorrect. I'll double check my solution in just a moment. So yeah, so everyone else saying I've got the wrong answer, so that's not a good start. Maybe I rendered incorrectly before, but yes, I'll change that then. So we'll try again. So 0.00271 there. There we go. There we go. So apologies. I don't know how I got that wrong. But the method I'm working with is correct, so that's always positive, right? So I've seen that somebody else already put here 1 minus the probability then of less than or equal to 2. Yes, perfect. So 1 minus then the probability that x is less than or equal to 2. Because we want everything less than, or we want to subtract everything less than that, right? So again, just grab your calculator here. This time now it's BCD because it's a cumulative probability here. So BCD here. Again, it'll want a few different things. It'll want N, it'll want P, and it'll want X here. So N and P are the exact same as the previous part. So N is 30, P is 0.05, and then for X here, that is 2, right? So input all of that into your calculator here. Everyone just do the same as me because I've already kind of worked it out, but I'm kind of doubting my answer now. So if I get something different to everyone else here, I will double check my answer. But what I got here is 0.1878, but I want everyone else to just double check that because I have a feeling either my calculator is tripping or I have done something silly. So just everyone quickly double check that for me. How long is the stream going to be? It will be approximately about 2 hours. I'm going to do something a little bit later on as well. Again, probably about an hour and a half a little bit later on. 0.1878. Okay, yes, perfect. We all got the same on that one. So I don't know what I did before. I don't know how I quite got that wrong, but perfect. So give that a tick. Give that a tick as well. Perfect. So good stuff, everyone. And just another kind of point here. A lot of these questions are from the old spec, so you shouldn't recognize a lot of them. There is a couple from the new spec. So you might recognize some of the questions we worked from, but hopefully a lot of these questions here should look a little bit different, right? So there we go then, hopefully nice and straightforward for question 1 there, okay? So let's move on to the next question here. A little bit of mechanics again, pretty straightforward just for the first mechanics question here. So what we've got here then is a particle P of mass 0.5 kg that moves under the action of a single force, F newtons. Now at time t seconds, the velocity v, meters per second of P is given by the following here. And we want to find the following 2 things. So for part A then, so for part A here, we want the acceleration of P at time t seconds, okay? So what I've got here is the velocity vector. So if I want the acceleration of P here, what do I need to do then? Someone give us a shout. What am I looking to kind of do to get to the acceleration of P? So yes, I can already see someone shouting out the answer here. I'll put it in the chat. Differentiate, yes, perfect. Because the way that I like to kind of mention this to students here is SVA. If you're going down here, and we differentiate with respect to time t, so d by dt. And if you're going in the opposite direction here, so if you've got the acceleration vector and you want the integration vector, sorry, the velocity vector here, then we integrate. Okay, so we integrate here with respect to time t, like so. Okay, yes, perfect. Everyone who's shouting out differentiate, absolutely spot on. So I've got v here. I'll just start by writing down the velocity vector here then. So that's 3t squared I. Plus then 1 minus 4t j, like so. So as we've already mentioned then, if I want the acceleration vector here, that is the derivative then with respect to time t of the velocity vector. Okay? So just go term by term here, hopefully nice and straightforward. Yeah, I can already see somebody shouting out the answer here. Perfect. So this term here, I just differentiate to give us 6t, right? So I get 6ti there. Don't forget the components here. And then this 1 minus 4t, that just differentiates to give us minus 4. So we get minus 4j there. Okay, like so. And there we go then. So nice and straightforward. But as you can see, that gives us the acceleration of P at time t seconds. Okay. Now for part B then, what we want here is the magnitude of F when t is equal to 2. So what law do we need to use here then for part B? Any ideas? Someone give us a shout. Yes, exactly. Perfect. Right. We're going to use F equals MA. The trusty friend. Yes, our trusty old friend F equals MA, right? Newton's second law here. So using F equals MA. Okay. So yes, perfect. Everyone who shouted out F equals MA, absolutely spot on. Or Newton's second law, if we're being a little bit more precise or fancy. There we go. So F here, let's just do this underneath then. So F here, I can't speak today, by the way. So F is equal to, so the mass here, as we're told in the question, is 0.5 kg. Big newt, I like that. Big newt, I'm going to use that in the future. So big newt, that will be added to my vocabulary. So F is equal to then, so it's 0.5 because the mass is 0.5 here. And then we times that by the acceleration here. So that's going to be 6t I, 6t I there, minus 4j, like so. If we simplify that here, I'm going to get 3ti, and then 0.5 times minus 4j, that gives us minus 2j, right? So minus 2j there. Yes, we are the inventors. I do like that, big newt. So when t is equal to 2 then, when t is equal to 2, just substitute that in, right? So what I get here then is F here is equal to, so it's going to be 6i minus 2j, like so. And then obviously, we just want the magnitude of this, right? So a little bit of Pythagoras, which is going to give us then, so the magnitude of F here is equal to, it's the square root then of, so we do 6 squared plus minus 2 squared, right? 6 squared plus minus 2 squared, like so. That's 36, that's 4, so I get root 40. We get root 40 there. And obviously I can simplify this, right? I can write this as 2 root 10. Yes, I can already see somebody mentioning that in the chat. So spot on there, 2 root 10, like so. And we'll put newtons there. There we go, big newts. So yeah, hopefully that wasn't too bad. As I said, for the first mechanics question there, pretty straightforward. But the key thing to remember here is if you're going down, so you've got the displacement or the velocity vector, or the displacement vector, I should say, then we differentiate to get to velocity or acceleration. And if you're going in reverse here, then we integrate with respect to time t. Okay. So perfect. Okay. So that's a solution to question 2. So let's just move on here then to question 3. And question 3 isn't particularly difficult, but it is one of those long, monotonous questions which nobody particularly likes. As you can see, you get a lot of waffle right at the start of the question. You've got a table of values here, and we just got a few different parts of this question here, right? So from part A all the way through to part E. So let's just quickly read through the question. So what we've got here is a sports scientist who believes that there is a relationship between the stride length L centimeters and the sprint speed V meters per second of elite female sprinters. A random sample of 10 athletes is taken and the relevant data is shown in this table below. Somebody's asked, can we leave it like that? R23 SF. I would accept that as it is in exact form. If you want to give it to free SF, then that's absolutely fine as well. Either's fine there, right? So, where was I up to? So I got to the table here. The sports scientist plans to use a linear regression model based on these data and interpolate or extrapolate as necessary to estimate the sprint speed of other elite female sprinters based on their stride length. Yeah, so a lot of waffle, but there we go. Pretty standard with these types of questions, right? So for A part 1 then, so it's actually 2 parts, A part 1 and part 2. with A part 1 here. And by the way, I'll probably run out of room for this question, but we'll see how far we can get, right? So for A part 1 then, briefly explain what is meant by extrapolation. So can anybody explain what extrapolation is as a statistical concept? Someone's put, isn't extrapolate where you predict a result based on previous results? It's close to that, but not quite. We're looking for something slightly more precise. Yes, there we go. So extrapolation is when we make an estimate that's outside our results, okay? So for example, then if I chose L here is equal to 200, that would be extrapolation because it falls outside this range of values here for L, right? As an example there, okay? So pretty similar to what you were saying before, MISO, where we use previous results. It's kind of close to that. We are making a prediction, but the predictions are outside the range of the data, basically. Okay, so let's just quickly summarize that here then. So extrapolation is when we make predictions outside the range of the data, right? Is when we make predictions that are outside the range of the data. Okay. And there we go. So that's A part 1 complete. And what about A part 2 then? What is the dangers of extrapolation? I mean, that is very dramatic, the dangers of extrapolation. But essentially, what is the problem with extrapolation here? Someone give us a shout here. A part 2. I mean, somebody might have already put it in the chat. I might have missed it. Let's just quickly flick through the chat. Someone's put there's a danger the value may not be valid. Yes, that's basically what we're looking at here. Or unreliable. The reason why is because essentially the trend might not continue, right? So that's the key thing here. The danger of extrapolation is that the trend might not continue. I mean, there's no guarantee. It could just continue and extrapolation might be fine. But yes, no guarantee that the data will follow the same previous trend. So it's unreliable. Exactly right. So let's just quickly summarize that as well. So extrapolation is unreliable. Extrapolation is unreliable. Is unreliable as the trend may not continue. Okay. And there we go. Again, it's just 2 marks for A part 1, part 2. It's just 1 mark each part. Don't write a novel. Just 2 quick points here is absolutely fine. Okay. So for part B then, again, just another 1 marker here. So the sports scientist attempts to calculate the product moment correlation coefficient R and obtains a value of 1.5. So without carrying out any further calculations here, explain why this product moment correlation coefficient must be incorrect. So what is wrong with this value here? Okay. Someone give us a shout. This should hopefully be nice and straightforward. Yes, exactly. Perfect. So I can see somebody already mentioning it in the chat, right? The R here is going to be between -1 and 1. So the issue here is that it's greater than 1, which isn't valid. So this sports scientist is not very good at stats, right? I think they would fail the stats part of the applied paper. So let's just quickly mention that point here then. So R is between -1 and 1 here. But we have R is equal to 1, right? So yes, perfect. I can already see a lot of people mentioning it, that it's between 1 and -1. So if this is 1.5, then it's clearly greater than that, and it must be incorrect. So R is 1.5 there, and therefore must be incorrect. Must be incorrect. Yes, the sports scientists should definitely just stick to sports and not maths. I don't think they'd be passing A-level maths. So there we go, right? So that's the solution to part B. For part C, then, again, just another one marker here. But this is an essential skill. Where's my pen gone? There we go. So part C here, it just says then, use your calculator to evaluate the product moment correlation coefficient. So what is the way to do this here? So grab your calculator. Hopefully you already know how to do this. If not, I'll just quickly run through how you would use your calculator to find the product moment correlation coefficient. So I have a very old graphical calculator, but I imagine if you've got any of the more recent, newer Casio graphical calculators, it will be almost identical. So we go into stats mode. I then press calc. So calc here. I've got regression. I've got X, and I've got A plus BX. Okay, so those are the choice that we want here to choose, but I actually need to enter the data first. So on your calculator in stats mode, you'll have list 1, you'll have list 2, you'll have list 3, so on and so on, right? Now, we'll need 2 lists here, so list 3, list 4, so on and so on. We're not bothered about that. So for list 1 here, I just enter the values of L here in this order. So 155, 160, 172, 150, so on and so on. So 155, 160, 172, so on and so on, all the way up to the very last value here, which is also 172. Okay, like so. We now do the same here for this second list of values. So 9.2, 9.3, 9.7, so on and so on. Now, the key point here is to just make sure then that these are aligned here. So the 9.2 should go next to the 155 in the list, the same for the 9.3 and 160, the same for the 9.7 and the 172 here. So 9.2, 9.3, that's supposed to be a 3, 9.7, so on and so on, all the way up to the very last value here of 9.8, okay, like so. So yes, perfect. I can only see people showing out the answer here. So just before I kind of write down the answer here, again, we go into stats mode, right? I then press calc, regression, X, and then click A plus BX, right? Make sure you've entered all of the data correctly here. And once you do that, it'll give you a few different things. But the only thing that we actually care about here is R, right? I'm not bothered about A or B or anything like that. All I want here is R, okay? So R here is just simply then 0.922597, so on and so on. If I round that to 3 SF, then I'm going to get 0.923 there, right? 0.923, okay? Does it matter if you do AX plus B or A plus BX? No. The only thing that we care about is R. If you do both of those, you'll get the same answer either way, assuming you've entered the list incorrectly. And yeah, that won't change anything. So AX plus B or A plus BX is absolutely fine. I always just used A plus BX. So that's what I've always used since being at school. But yeah, either's fine there for the PMCC, right? Using your calculator. And there we go. So it's just one mark. You don't need to write all this nonsense. This is just me kind of showing how to do this using a calculator. But in your exam, just write down the value, right? So there we go then. That's the solution to part C. For part D then, so for part D here, it says, stating your hypotheses clearly, test at the 1% significance level whether or not there is evidence that the PMCC for the population is positive. Somebody's just asking as well, how do you know which one to choose? It really doesn't matter. You can choose either. As long as you just kind of write down R equals and then the value, then that's absolutely fine. You won't get penalized if you choose AX plus B or A plus BX. It will be the same answer either way, right? So for part D then, what I'll actually do here is I'm just going to quickly clear the screen. You will need your answer to part C here. So I'll just write down again here. The R is equal to, what did we get? 0.923, right? 0.923. Okay. So this is a hypothesis test, right? And what I always say here, if we're hypothesis testing, just start with the actual hypotheses here. So we've got H0 and H1 here. Now, when we're testing for PMCC here being equal to 0, so we're testing for 0 correlation here, right? Then we use the Greek letter rho here, which is kind of like a funny P, like a P that's kind of like slanted, like so, something like that, right? So H0 is always rho is equal to 0. That never ever changes no matter what the test is here for correlation. But H1 will change depending on the context of the question. So that's up to you to read the question carefully. Just make sure then that you've picked out the, the context correctly here. So to do that then, let's just go back to part D here. So what we're testing here then is at the 1% significance level, whether or not there is evidence that the PMCC for the population is positive. So what I'm testing here then is that rho is strictly greater than 0, right? If it's positive correlation, then rho must be greater than 0. If it said the PMCC for the population was negative, then that would be strictly less than 0, right? And then the final option here is when we're testing whether there is a change in the PMCC, and in that case, it would be a two-tailed hypothesis test where H1 is rho not being equal to 0. That is the final type there. So just be aware of the 3 different choices that we have here for H1. Okay, so that's H0, that's H1. Your test statistic here, that's always a tongue twister. That is the value of R that we just found in the previous part. So therefore then, the test statistic, which I just abbreviate to T.S here, that's 0.923. Now, for the critical value here, I am kind of missing the formula book. So you will need your formula book here for the critical value. So hopefully you've got it to hand here. So make sure you're on the correct table here. For the critical values here for the PMCC, it's also next to Spearman's rank table. So the first thing to mention here is that you make sure you're actually reading from the correct table here. If you read from the wrong table, then this will be a travesty. It will be incorrect. So just be careful for that, right? Now it's one-tailed, so we don't have the significance level here. If it's a two-tailed hypothesis test, then you would divide the significance level by 2. But in this case here, it's a one-tailed test, right? So we use the 1% significance level here. N, as we're told at the top of the question here, N is equal to 10. So if you've got your formula book to hand here, somebody just shout out what they got for the critical value. Hopefully we do get the same here. And while somebody does that, I'm going to grab a drink. What did we get, people? Come on, surely somebody's got their formula book to hand. 0.7155. Yeah, somebody's put 0.7255. I think they mean, 0.7155. Perfect, exactly right. So we can all obtain the correct critical value. That is a positive thing. So 0.7155 there. So what we now do here is we compare 0.923 to this here, the critical value. So 0.923 is greater than 0.7155, right? And yes, I can already see somebody mention it here. We do reject H0. So H0 stinks. We're going to reject it. So therefore, we reject H0. We reject H0 here. And what you should always do then for these types of questions here is you should kind of go back to the context of the question here and kind of just link it back to what the question is actually asking, right? So what I'm going to say here then is there is evidence that the PMCC for the population is positive, right? Because that's what we're, being asked to test here. So there is evidence. There is evidence. There is evidence at the 1% significance level, 1% significance level. I mean, you don't have to write this part here. I'm just being very precise. But there is evidence then at the 1% significance level that the PMCC for the population is positive. The PMCC for the population is positive. Okay, and there we go. So that's 3 marks there in the bag. Normally, these kind of questions here on correlation and hypothesis testing for zero correlation, they're normally pretty early on in the paper. Not always, but generally, it's usually like question 1, 2, or 3. Very occasionally, it kind of makes its way to question 5 or question 6, but that's when we have non-linear regression, okay? But there we go then. So that is the solution to part D. And then finally, to finish with here, we have part E, right? So for part E then, it says, explain what your test in part D suggests about the elite female sprinters. Just 1 mark for this. So again, we don't need to go into too much detail here. But basically, kind of just link this back to the context of the question here, right? Where we're looking at the stride length here, or the relationship between the stride length, L centimeters, and the sprint speed, V meters per second of elite female sprinters. Now, if we're saying here, basically that we have positive correlation, right? Then this would suggest here that on average, elite female sprinters with a greater stride length, they will have a faster sprint speed, right? Which intuitively does make sense. So this suggests then, yes, exactly perfect. I can see people showing out the answer. Exactly right. So this suggests then that on average here, this suggests that on average, elite female sprinters, I can't speak today, with a greater stride length. There we go. With a greater stride length. Have a faster sprint speed. Which again, seems quite intuitive, right? That is what you would kind of expect here. And that's what we found here. So they have a faster sprint speed. That, by the way, is supposed to be an S. It's funny looking. There we go. So there we go then, right? It's just 1 mark. It doesn't need to be a novel. But there we go. Okay. So hopefully nothing too bad there for question 3. If you've got any questions, just shout them out as we're going. I will try and go back to answer questions as I'm kind of going here. But yeah, let's just move on for now then. So that's question 3. So for the next question here, question 4, we have a mechanics question, right? So there's just the 1 part to this question here. It's not split over multiple parts. What we can see here then is figure 2. And what I've got here then is a particle P of weight 40 newtons, which lies at rest in equilibrium on a fixed rough horizontal surface. A force of magnitude 20 newtons is applied to P, as we can see here, right? Now the force acts at an angle theta to the horizontal, as shown in figure 2. The coefficient of friction between P and the surface is mu. Given that the particle remains at rest, show then that mu here must be greater than or equal to cos theta all over 2 plus sine theta. Right, so any ideas what we can do here to begin with? Someone give us a shout what we're going to do to begin with here. Any ideas, anyone? So yeah, so first thing we should do here is start by labeling the forces. I mean, they've kind of drawn on this diagram here. If you want to, you can just use this diagram here, but I generally just like to draw my own diagram. And then, yes, as other people have mentioned as well, we're then going to resolve the forces, right? So what I'll do here is I'll just draw a separate diagram, something like that. We've got our particle here, something like that, right? So this here is the particle P, okay? So let's just add the relevant forces here. We're going to have a normal reaction then between the particle and this fixed rough horizontal surface, right? That's going to look like that. We'll label that as R. What else have we got here? We've got the weight force acting vertically downwards. So a particle P of weight 40 newtons. So that force then is 40 acting down like so. 40 newtons there. And then what else do we have to account for here? Well, we're on a fixed rough horizontal surface, so we do need to account for friction here, and obviously that's the whole point of this question, right? Which, you know, we're looking to show that mu is greater than or equal to cos theta all over 2 plus sine theta. So friction. So if the force is pushing on the particle like this here, then friction will act in this direction, right? Or we will assume it will act in this direction here. So I'll label that here as F, like so. You can also label that as mu R if you want to, but it's completely up to you. So what I'm also going to do here as well is this force, right, of magnitude 20 newtons, I need to split that up into components, okay? So that force is like so. This is going to be 20 newtons, or it has a force, it's a force of magnitude 20 newtons. There we go. That was difficult. And then if we split it up into components, what are we going to get here? So I'm going to draw it like this here as a right angle triangle, like so. I've got two components here. So we've got this component here, which goes down right, like so. And then I've got this component here to the right, okay? So for the vertical component here, what would you guys label this component here? And by the way, this angle is theta. So apologies, my diagram isn't the prettiest, but for the vertical component here then, what would you guys label this? Yes, 20 sine theta, perfect. There was a 200 sine theta, but I presume they mean 20. So yeah, perfect, right? 20 sine theta. And as you can see here, it's a lot easier if you draw your diagram a little bit bigger than I've done here. But we also have the horizontal component here, which I don't have a lot of room for. I'll try and squeeze it on underneath then, which is going to be 20 cos theta, right? Like so, okay? So, as people mentioned before then, let's now just resolve here. So we'll start by resolving taking upwards as positive here. We'll resolve taking up as positive here. If I do that then, what will I get here? So R here, the force acting up, is going to be equal to then, so it's going to be equal to the weight force acting down right. That's going to be 40. Like so. And then we've also got the vertical component here, 20 sine theta. So that's going to be 40 plus 20 sine theta, like so. That's when we resolve vertically there. I've took up as positive, like so. And now let's resolve horizontally here. My pen keeps going. There we go. So let's just resolve here horizontally. I'll take to the left as positive, but it doesn't actually matter, right? I'll take to the left as positive here. So what forces have we got here to account for then in the horizontal sense? So what am I going to get here? I'm going to get them. So I've got F here. That's acting to the left. So that's positive. And that'll just be equal to them. So that's going to be equal to this horizontal component here, which is 20 cos theta. There's 20 cos theta there. There's no more horizontal forces, right? So that's fine. I'm just making sure that I haven't made any silly mistakes. So that's fine there, right? So I've got those two equations there once we resolve. So I've resolved vertically here, giving us r is equal to 40 plus 20 sine theta. And then resolving horizontally here, I get f is equal to 20 cos theta. And that looks perfect up to now. I can't spot any silly mistakes here. Now, what we're told then is the particle, or what we want here, is for the particle to remain at rest, right? Now, for the particle to remain at rest then, so for the particle to remain at rest, then what do we require here? Don't do it, pen. My pen's going to break. So what do we require here? Something to do with F, right? Someone give us a shout when they think they've got it. Yes, perfect. So I can see people shouting out here. What we want then is friction to be greater than or equal. So we want friction to be equal or greater than 20 cos theta. Well, let me just change that. Sorry. So I want R here. So I'm saying that F is greater than or equal to mu R. Okay. So what have we got here then? So we're going to get, here. So F is this, right? 20 cos theta. Let's just substitute in the appropriate things here. So F is 20 cos theta. That must be greater than or equal to, that's going to be greater than or equal to mu R. So mu, we don't know what that is, right? So we're just going to leave that as mu. R here is this, right? When we resolved before. So that's 40 plus 20 sine theta. Okay. So let's just keep going here. Now, what I want then is just mu on its own, right? As they've got here. So what I can do here then is just divide both sides by 40 plus 20 sine theta. So what I've got here then is, yes, I should have put this the other way around, sorry. So this should be, so F must be less than or equal, sorry, to this here. Sorry, I've made a mistake. Yes, I was going to say this isn't going to work out otherwise. I'll actually just erase that on here. Apologies. There we go. F is less than or equal to mu R. There we go. Like so. I was going to say this isn't going to work out otherwise. So now divide both sides by 40 plus 20 sine theta. So I get 20 cos theta is all over then 40 plus 20 sine theta. Like so. That's less than or equal to mu. Like so. You're not allowed to screw up AJ Maths lock-in. I know I'm not locked in this morning. I'm struggling. So let's just continue from here. Apologies. Now, if this here is less than or equal to mu, that's the same then as saying, I'll just do this up here, that mu is greater than or equal to then 20 cos theta, 20 cos theta all over 40 plus 20 sine theta. Okay, like so. So what I can just do here then is just simplify, right? We can divide both top and bottom here by 20, right? If I do that, cancelling through with each term here by 20, right? So 20 cos theta divided by 20 is just simply cos theta. So therefore then mu here is greater than or equal to I get cos theta. So cos theta all over. So 40 over 20 is 2. And then 20 sine theta divided by 20, that's going to give us sine theta, right? So I get 2 plus sine theta. So feta cheese there. There we go. And as you can see then, we've got exactly what they had here, right? We've now got the exact same here as what we wanted. So what I put here is as required. You don't have to put this, by the way. But I always like to kind of say as required here and drop a smiley face in just to show the examiner that you are a boss. So there we go, right? So 6 marks for that. As you can see, it is very easy to make a mistake if you're not paying attention like I did before. So yeah, just be careful for that. Someone put cold. That was cool, right? But there we go. So hope that wasn't too bad. What question are we on? That was question 4, right? So there we go then. That is the solution to question 4. So let's move on to question 5 here. We're pretty much at the halfway point at this point, right? So let's just continue with this question here. Question 5. Someone's put, what if you don't draw a diagram? Do you still get 6 marks? Yeah, you don't have to draw a diagram. I just think it's useful to draw the diagram. A lot of the time, students try and get away with not drawing diagrams for mechanics questions, and I don't advise that. If you can, just draw a quick diagram. It makes the questions a lot easier, right? But no, you don't get penalized if you don't, draw a diagram. You would still get 4 marks, assuming that the working is correct, right? And you can also just use their diagram as well. That is also fine, but I just find it easier to just draw my own diagram, okay? So let's move on to this question here. This is question 5, right? So for this question here, we're talking about salmon. Yeah, it's interesting. So what I've got here is Jim, who records the length L millimeters of 81 salmon. So he codes the data using this equation here, and he obtains the following summary statistics. So I've got N, I've got sigma X and sigma X squared, right? And for the first part here then, we just want to find the mean length of these salmon. So for part A then, here, we want to find the mean length of these salmon. So before we do anything else then, let's just find X bar here, okay? Because what I will need here is X bar to want to find the mean length of these salmon, right? So, and by the way, someone's put how he's finding the mean 3 marks. Well, one, this involves coding, so it involves a little bit more work than a regular kind of like finding the mean question. But these are from the old spec, so to be honest, the marks, the allocation of marks was a lot more generous. So yeah, so possibly 2 marks, I would say, for this one here. So let's just start by finding X bar here. So for X bar here, that is going to be then, so it's going to be sigma X over N, right? So sigma X over N. So sigma X here, that is 3,711. Like so. And we divide that by N here, which is 81, okay? So just throw this here into your calculator. I get 45.8148, so on and so on. So 45, what did I say then? 8148, so on and so on, okay? But what we want here then is L bar, right? So I want L bar here. Now this is X is equal to L minus 600. So I'm going to add 600 here to both sides, right? And then for L bar here, that's going to be X bar plus 600, okay? So X bar plus 600, okay? So L bar is equal to X bar, which is this here, so 45.8148. So 45.8148 plus 600, like so. And what I get here then is 645.8 millimeters there, okay? So you could round that to 3SF as well, 646. It doesn't really matter as long as you've kind of got it to either this here or 3SF. That is absolutely fine, right? And there we go then. So that's the mean length of the salmon. Somebody already kind of mentioned it here as well, that the standard deviation doesn't change. Yes, that's absolutely spot on here. So the standard deviation here won't actually change. So that was A. Let's take a look at B here. So for part B then, let's just start here by finding the variance for X. So that is going to be, so it's going to be sigma X squared over N minus X bar squared. We'll just start by finding this here. So sigma X squared over N minus X bar squared. Okay. So let's just evaluate this here. So sigma X squared is this here. So 475,181. So 475,181. That is over N, which is 81 minus X bar squared. So X bar we found in the previous part. I did not mean to do that. So let me just quickly erase that. So yeah, so X bar we found in the previous part, which was 45.8148. Okay, so minus then 45.8148 squared. Really, I should probably put it as this fraction here. So 3,711 over 81 squared. I'll do it like that, just to be precise here. So apologies, let me just quickly do that again. So minus then 3,711 over 81 all squared. Okay. So again, just throw this into your calculator, right? And what we get here then is 3,767.43. Okay. Now, this here is the variance for X, but somebody's already pointed out before, the variance won't actually change here. So the variance of X is the same then as the variance of L. So therefore then, to finish with here, let's just state this as the actual variance of L rather than giving it as the variance of X here. So var L here, the variance of L is, it's going to be then this here. I'll round this to 3SF then, which would give me 3,770 here, like so. But again, if you give it like this, you're not really going to get penalized, right? So there we go then. That's the solution to part A and part B. For part C then, we've got a box plot, right? Which is generally a positive sign that the question is going to be quite nice, right? So for part C then, what does it say here? So it says then, somebody's put how he's finding the mean marks more than finding the variance. The reason why is because this question is using coding, right? Because for the mean, you do need to kind of rearrange this here and add on the 600. For the variance, you don't actually add anything to this, right? The variance for X here is the same as the variance for L. So I guess there is kind of an extra step here in finding the mean when you add the 600 on. This here, you don't need to account for that. The variance for X is the same as the variance of L, right? So yeah, so that's why probably they gave an extra mark there, but blame Edexcel for that, not me. I didn't write this paper. So yeah, it's an old spec question. The marks were a little bit funky, but there we go. So for part C then, what we're told here is the way W grams here of each of the 81 salmon is recorded to the nearest gram. The recorded results for the 81 salmon are summarized in the box plot below, as we can see here. So for part C then, we want to find the maximum number of salmon that have weights in this interval. So between 4,600 and 7,700. It is just one mark here, so we shouldn't really be expecting too much work, okay? So if you look at the kind of like box plot here, right? What I can see then is the median here, Q2, that is 4,600, right? So if there's 81 salmon, the median is going to be the 41st value here, right? So if there's 81 salmon, so if we have 81 salmon here, then the median is going to be, as we just said, the 41st value. The 41st value. Okay. So my question to you guys now then is, what does that mean here? The maximum number of salmon that have weights in this interval must be. What would you put here? Any ideas what someone would put? Yes, I can see 40 there. Perfect. How did I get the 41st value? Because it's the median, right? There's 8 ones happening in total. So the median would be the 41st value, right? Imagine you were to kind of like write down the 8 ones happening in a row. For the median, then you would add 1, divide by 2, right? So 82 divided by 2. Did I say divide by 1? I meant divided by 2. That would give you the 41st value there, okay? And as you've already mentioned, or someone else has mentioned here, the maximum number is 40. Yes, perfect. So in that case then, the maximum number here, so the maximum number greater than 4,600 is therefore the remaining 40 values, right? Is the remaining 40 values. Remaining, can't spell. Remaining, is that how you spell it? 40 values. There we go. So hopefully that makes sense. It's just 1 mark, so you don't need to kind of put too much work into it. So there we go. Okay. So that's part C. And then for part D here, pretty common type of question here. We've got Raj who says that the box plot is incorrect as Jim has not included outliers. Now for these data, an outlier is defined as a value that is more than 1.5 times the IQR above the upper quartile or 1.5 times the IQR below the lower quartile. So for part D, then we want to show that there are no outliers here. So let's just start by finding Q1 and Q3. Again, this is just basically GCSE maths, right? Because we just go back to the box plot here. So this is Q1, which is, so what is that? That's 3,800, right? 35, 36, 37, 38. So that's 3,800. So let's just do this underneath here. So part D then, Q1 is 3,800. And then for Q2 here, that was 4,600, but we don't need that, right? Because we want to consider the IQR. And then Q3 here, the upper quartile, that is this one here, which is, that is 5,400, right? 5,400 there. So the IQR here, the interquartile range, that's the difference between 5,400 and 3,800. 3,800. And that gives us 1,600. 1,600 there. Okay. Now, what I'm going to do here then is find the boundaries for the outliers, right? So anything that would be below that would be an outlier, and anything above that would be an outlier as well, if you get what I mean. So for the boundaries here, let's just do that underneath then. So for the boundaries here, what we have then is, so we're going to have 1.5 times the IQR above the upper quartile or 1.5 times the IQR below the lower quartile. So let's just start with this one here for the lower boundary essentially, right? So that's going to be Q1 minus then 1.5 times the IQR. Okay. So we're going to have then Q1 minus then 1.5 times the IQR, which is 1,600 as we've just evaluated. So Q1 is 3,800. So I do 3,800 minus then 1.5 times 1,600. So that is 2,400, like so. And then 3,800 minus 2,400 gives us 1,400, right? Just like that. Okay. So that is the lower boundary here. We'll now find the upper boundary. And in a similar fashion, or it's pretty similar, I should say here, we're now going to do Q3 plus then 1.5 times the IQR, right? The interquartile range. So it's going to be Q3 plus then 1.5 times the IQR, which is this here. 1,600, like so. So what's that going to give us here? So that is going to be Q3, which is 5,400. And apologies, by the way, my presentation is getting a little bit messy down here, but let's just continue. 5,400 plus then 2,400. Add these together, I get 7,800, right? 7,800 there. Okay. So what we now do here is we go back to what we've got here for the box plot, right? So what can we see here? So I can see here then that the minimum value, this is the min value here, that is 1,600. That's 1,600. And then for the maximum value here, that is 7,677. That's 77. Yes. 7 there. For the maximum value, right? So because then what I've got here is 7,700 for the maximum value, but we've said anything greater than 7,800 would be an outlier. So there's nothing in terms of the upper boundary here that would give us an outlier. And the same again, if we refer to the lower boundary here, anything below 1,400 is an outlier. Well, our smallest value here is 1,600. So we know then that we have no outliers, right? So what I'll just say here then to finish with is, I'll do it with the smaller one first. So 1,400 is less than 1,600. So there's no outliers there for the lower boundary. And then for the upper boundary here, we have 7,800 is strictly greater than 7,700. Okay. Like so. So therefore then, we have no outliers. Okay. And there we go then. So hopefully it makes sense what we did there for part C and part D. They're a little bit more involved, I would say, than part A and part B. But again, all things considered, I don't think this question, is too bad, right? So there we go then. So that was, what question was that? Question 5, right? So we're halfway through at this point here. We'll just take a quick 30-second break. Everyone can kind of read over this question here, which is on projectiles. So that's always fun, right? So yeah, I'm just going to grab a quick drink. But let's just kind of have a quick 30-second break. Right, so question 6 here, another mechanics question. This question is a projectiles question. Edexcel do love a good projectiles question, and we've got this one here. This was from a paper a few years ago now, off the top of my head. I think it's 23. I think it's either 22 or 23 that this question came from. If you are looking for more projectiles questions, this did used to come up on the old Edexcel M2, but you do need to be slightly careful because sometimes those questions use something called energy. So if you do physics, you'll be familiar with that concept. But if you're just doing A-level maths here and you don't do A-level physics as well, or A-level further maths, then they might get a little bit confusing. So just kind of keep that in mind if you're going to go through any further questions using the old Edexcel M2 papers, right? But anyway, let's just start then with this question here. So I'll write part A right at the very top here. So let's just quickly read through the question here. That is always a good starting point, right? So what we've got here then is a small ball that is projected with a speed of 28 meters per second from a point O on horizontal ground, as we can see here, right, from our diagram. Now, after moving for t seconds, the ball passes through the point A, as we can see here, like so. The point A is 40 meters horizontally and 20 meters vertically from the point O, as shown in figure 2. So the motion of the ball from O to A is modeled as that of a particle moving freely under gravity. And it says, given that the ball is projected at an angle alpha to the ground, we want to use the model then to show that t is equal to 10 over 7 cos alpha for the first 2 marks here, right? So, right, where do we begin here? To be truthful, I hate these questions. I mean, I am not a natural physicist or mechanist. I don't really enjoy mechanics, to be truthful. So I hate these questions. But if you do enjoy physics and mechanics, this is probably quite straightforward, right? So what I will do here is just consider the motion in two separate parts. We've got the horizontal motion here and the vertical motion as well. And what I'll also do here as well is, I'll underline those, but that wasn't what I was going to say. What I will do here is just draw a separate diagram. So I'm not going to go into too much detail. In fact, let me just kind of add it to this one here. I don't need to do a full separate diagram. Imagine that goes up like that. It should be a straight line, but we'll roll with it. And imagine we kind of extend here along the bottom, right? Like so. What I want to do here then, split this into components. So imagine you split this up into components here, forming a right angle triangle, something like this. Okay. So we've got this component here and this component here, like so. So we'll involve you guys again here. What would this component be here? So this component here, the vertical component, what would that be? In the context of this question here, right? What would that be? Someone give us a shout. Come on, surely someone's got this component. Give us a shout. If not, I'll put it in about 30 seconds. If not. Yes, perfect. So the vertical one here, yes, two people already shouted it out. 28 sine alpha, perfect. So 28 sine alpha. And then in that case, the horizontal one here is going to be 28 cos alpha. 28 cos alpha. Okay. Yes, perfect. Vertical sin component, horizontal cos. Perfect. I think his chat is delayed. I think there is just a little bit of a delay between kind of what I'm writing and what gets shown in the chat. So yeah, apologies if it is delayed. It's a slight delay on my end, but never mind. So perfect to everyone who shared out the solution. So as we said before then, let's split this up into two different parts here, horizontal and vertical motion. I'm going to use trusty old SUVAT here. So S, U, V, A, and T. Same again here then for vertical, right? So S, U, V, A, and T. Okay. So for S here for the horizontal, that's going to be 40, right? Because we know this displacement here is 40 meters. So S is 40 there. And then for the vertical displacement here, that's just 20, right? So that is just 20, like so. For U here, so those are the components. Someone's put, it's to prevent us stream sniping his ranked mechanics lobbies. Yeah, true. I am challenger at applied. So yeah, so U here is the horizontal component. So U here, the horizontal component, that is 28 cos alpha, as we denoted before. So 28 cos alpha. To be honest, guys, I don't really know why there is a delay. We can't pre-fire our question answers. I like that. Yeah, so yeah, 28 cos alpha there for U. And then for vertical U here, what we get then is the vertical component, right? 28 sine alpha, like so. Okay. So for V here, there's nothing relevant for either of these, right? So V would just leave blank. For A here, in the horizontal sense, the acceleration is just 0. And what I should have probably done here is define which way I was taking positive. So for the horizontal then, I've took to the right as positive. So to the right is positive. And then for vertical here, I'm going to take up as positive. I'm going to take up as positive here, like so. And then for A here, for the vertical one, if I took up as positive here, then A would be minus G, like so. And then for T here, for both of these, it's going to be capital T, like so. Okay. Right. So going from here then, I can see some people already kind of jumped to the solution. You can kind of just jump to the solution here, but what I am going to do is just kind of list everything out in full, because we can use it for the, the later parts of the question anyway, right? So for part A then, what we're going to do here is use s equals ut plus a half at squared, but obviously a is 0, so it just simply becomes s equals ut, right? So using here, s is equal to ut plus a half at squared. So, as we said before, a is 0 here for the horizontal motion. So in that case, then, it just simply becomes s equals ut, okay? So let's just substitute everything here from the horizontal motion. So, s here is 40. I've got 40 is equal to ut. So u is 28 cos alpha. And we times that by t here, which is t. So there we go. I get 28 t cos alpha, like so. And then, as we said before, this bit here is just 0. You don't need to write plus 0, but I'll do it anyway, just to show that it becomes 0, right? So, obviously, that just goes. I get 28t cos alpha is equal to 40. And what we're looking to show here then is that t is equal to 10 over 7 cos alpha. As we can see, this is starting to take shape pretty nicely, right? If I divide both sides then by 28 cos alpha, then what I get here is t is equal to 40 all over 28 cos alpha, like so. And then you can just simplify down here, right? So 40 over 28, that's the same then as 10 over 7, right? So I get 10 over 7 cos alpha. Exactly as they've got here. So as required, bosh. As required. And there we go. That's part A done. Yes, again, I appreciate that I've gone into quite a bit of detail there. Just kind of show everything. Yes, you don't need to write down the full plus a half at squared, but I'm just doing it just to show everything here, what's going on. As I said before, you can just save time, just go straight into s equals ut there, okay? But anyway, that's part A done. Now for part B, probably the trickiest part of this question here, we want to show this quadratic equation here. So part B then, I'm probably going to run out of room here. Do I start fresh? Yes, we'll start fresh here. But that's going to be a little bit annoying because I'm going to have to write this down again. What do I do? Someone's put, how does it become 0? I presume you mean for this bit here, sorry. So this bit here, that becomes 0 because A is 0. So because A is equal to 0, right? So yeah, because the acceleration is 0 there, then that's fine. That just becomes 0 for the full expression. And it just becomes s equals ut, okay? So do I start fresh here, or do I just try and continue underneath? I think I'm going to need more room. So that is annoying. I'll quickly clear the screen. Let me just quickly add on everything again here. So I've got my vertical component here. I'll just quickly add it all on again. Apologies for 28 sine alpha. And that was 28 cos alpha. As you can tell, I'm really happy with this. So we get those two components. And do I really need it again? The full suvat? I'll just do it. So for horizontal, I'll label that as H. I've got S, U, V, A, and T. S was 40. I had 28 cos alpha. 28 cos alpha. V we had nothing for. A was 0, and then T was capital T. I mean, we know that T now is 10 over 7 cos alpha. So you can just replace that at this point here, but that's absolutely fine. And then for the vertical motion here, again, using suvat. Trusty old suvat here. Let's just rewrite everything that we had here. So that was 20. U was 28 sine alpha. V we had nothing for. A was minus G. And then T was capital T. But again, you can just replace that with 10 over 7 cos alpha. That's absolutely fine. So for part B then, we're going to use again S equals ut plus a half at squared, but this time now for the vertical motion here. Okay. So again, using S is equal to ut plus a half at squared. What we're going to get here then, so S is 20. We've got 20 is equal to ut. So that's going to be 28 t sine alpha, right? So 28t sine alpha, just make sure I'm doing this correct. 28t sine alpha, like so. I've then got half times a, so that's minus g, unless told otherwise, take g to be 9.8, right? It's going to be a half times minus 9.8, and then we times it by t squared, so that is t squared there, okay? Now, we're going to replace t here with this, okay? Again, even if you couldn't get this here in the exam, you can still just use it without proof here. That is absolutely fine, and you won't get penalized for that. Okay, you'll get penalized if you can't get it. You're not going to get the marks, but you can just use it again in the next part of the question here. So let's just replace everything here that we've got. In fact, let me just simplify first. So I've got 20 is equal to 28t sine alpha. Half times minus 9.8, that's minus 4.9. So I'm going to get minus 4.9 there. Minus 4.9 t squared. Okay. So now let's just replace t here with this. I've got 20 is equal to, so it's 28 times then this here. I'll put that at the end then. So it's going to be 28 sine alpha. So 28 sine alpha times by t, which is 10 over 7 cos alpha. So 10 over 7 cos alpha, like so. And what else do we have here? We've got minus 4.9. So minus 4.9 times t squared. I'm going to times that then by 10 over 7 cos alpha squared, like so. Okay. Hopefully at this point here, everybody is following along all right. So let's just simplify here. So I've got 28 sine alpha. I'm going to times that by 10 and then divide by 7 cos alpha. Now, sine alpha over cos alpha is tan alpha, right? And then 28 times 10 is 280. Divide that by 7, and we get 40 there. So I've got 20 is equal to 40 tan alpha. So 40 tan alpha there, like so. And then let's just simplify this here. So that's going to be 100 over 49 cos squared alpha. So what's that going to simplify to then? That is going to give me minus 10 over, that's going to be cos squared alpha, right? Yes. So minus cos squared alpha. If you want to, you can write down the full expansion there. That's going to be 100 over 49 cos squared alpha, and then it'll just cancel down quite nicely. So what are we going to get here then? Or what can I do from here, I should say? Again, probably the trickiest part of the question now is spotting how we go from this line of working here to somehow ending up at this point here. So any ideas then what I can do at the next step here based on this line of working? Someone give us a shout. And I'll give a little bit longer because apparently there is a little bit of a delay here. Yes, perfect. I can see somebody mentioning them. We're going to use the identity of sec squared being equal to tan squared plus 1. Perfect. Okay. So using our trig identities here to help us progress then. So what I'll do here is I'll try at the top then, rather than kind of just putting it in the middle here and confusing people. Yes, exactly perfect, Bab. So as we said before then, I can write this here as minus 10 sec squared alpha, like so. And using here then, so using So using here, sec squared alpha is equal to 1 plus then tan squared alpha. And what we've got here is minus 10 lots of this, right? Minus 10 lots of 1 plus tan squared alpha. So let's just go back to this line of work in here. What we've now got here then is 20 is equal to, so it's 40 tan alpha. Can't do anything with that just yet. So 40 tan alpha. This here is minus 10 sec squared alpha. Using this here, I can then write this as minus 10 times 1 plus tan squared alpha. So if we just expand that then, what I get here is minus 10 times 1, so that's minus 10. And then minus 10 times tan squared alpha, that's minus 10. Minus 10 tan squared alpha. Like so, okay? And that is perfect up to now, right? So we've got a quadratic equation here. I can't speak. So a quadratic equation here. And that's positive, right? It's tan squared alpha. So what I'll do here is take this minus 10 tan squared alpha over to the other side. If you want to, you can just start simplifying at this point here and cancelling down. But I'll take everything over to one side first and then just cancel down, right? So I get 10 tan squared alpha, like so. I'm going to subtract 40 tan alpha from both sides here. So minus 40 tan alpha. And I've got 20 plus another 10 here. And that gives us plus 30. And this here then is equal to 0. And we're pretty much there now, right, people? So just divide through by 10 here. So what we get then is tan squared alpha. So tan squared alpha minus 4 tan alpha. Minus 4 tan alpha plus 3 is equal to 0. Bosh. As required there. Somebody put before, put QED. I don't normally put QED, but why not? QE. Whatever it stands for in Latin, quantus, something, demonstratus, or whatever the hell it is. There you go, QED. So that's the solution to B. So that's the 5 marks there. Absolute cinema. So that's part B done. The part C then, it says, find the greatest possible height in meters of the ball above the ground as the ball moves from O to A. Right, so what I'm going to do here then for part C is just solve this quadratic equation here, right? Someone put, bro's going to have to speed it up a bit. It doesn't have to run for 2 hours. If it runs over a little bit, that's fine. There's only a few more questions after this, right? So we'll just keep going. Solving this here then. I'm going to do this underneath. I'm probably going to run out of room again, but never mind. There we go. Quad erat demonstratus. I don't know if that's even how you pronounce it. I don't speak Latin, but there we go. Anyway, if you solve this here then, we get 2 solutions. I get tan alpha is equal to 3, or tan alpha is equal to 1. Okay. So, what I can do here then is just solve for alpha, right? Because I do need the values of alpha here to find the greatest possible height. And what I want then is the largest of those 2 values of alpha, right? So, tan alpha is equal to 3. If you solve that here then, alpha is equal to arctan of 3, which gives us 71.6, right? 71.6 degrees there. And then this one here, that's just simply 45 degrees, right? 45 degrees there. So we're going to use this one here, 71.6 degrees. That's going to give us the greatest possible height here in meters. So I don't have a lot of room. Let's just try and fit all of this in here. What I'm going to use then is, so I'm going to continue with part C up here. Hopefully you can just about follow along. So using V squared is equal to U squared plus then 2AS. Okay. So V here, that would be 0 because it's the greatest possible height, right? So at its greatest possible height, V is equal to 0. So V is equal to 0. So I get 0 squared is equal to U squared. So U here This is going to be for vertical motion, by the way. So we're using this one here. Okay, so using this one here. U then is 28 sine alpha, but alpha here is the largest of those two values of alpha, right? So alpha here is 71.6. So I'm going to get 28 sine of 71.6 squared, like so. And then it's 2AS. So, as you can see, I don't have a lot of room here. This is pushing it tight or pushing it close. I'm going to get 2 times A, which is minus G, so minus 9.8 there. And then I times that by S here. So what I'm going to take for S here, so the displacement here, I'm going to call that H, the height, right? The greatest possible height here, H. That's 0. So I'll just continue underneath here. So that's 0 is equal to, so I'm going to get 28 sine 71.6 squared. That is 705.6. So 705.6. This here then is minus 19.6 H. But what I can do then after is just take that to the other side, right? It's minus 9.6 H at this point here. Take that over to the other side then, which you can kind of just do all in one step here. But I'm showing all sets of my work in here. So apologies, I'm just kind of waffling on, but never mind. So 19.6 H there is equal to 705.6. And as you know, I saw quite a few people mention before, divide through by 19.6 here. And what we get then is H here is 36 meters, right? Which I saw quite a few people put before in the chat. So if you put that, perfect, good stuff. Well done. You got the solution. Okay. So for the final part then, part D, let's just fit that up right at the top here. Part D. It says this model does not include air resistance. State one other limitation of the model. Someone give us a shout then. What other limitations can we put here? There's quite a few that you can put, but anything that's kind of relevant here would just get you the 1 mark. But anyone give us a shout. What would you put here? And then I'll put my assumption as well, what I would choose. Yes, exactly right. Someone's put the ball is on the moon. I'm not sure that's going to get you the 1 mark, fam, but you roll with that. So yeah, someone's put does not consider the dimensions of the ball. That is absolutely fine. That's what I would put as well. Or you could put spin of the ball. Either of those is absolutely fine. So yeah, I'm going to put one of those, either the spin of the ball or the dimensions / the shape of the ball. Wind speed as well, yes. Follows the path perfectly. Again, yes. There's quite a few that you can put here. Any one of those is going to get you the mark. Okay. So, as I said before, spin of the ball. So spin of the ball. You could also put here, doesn't consider the dimensions or the shape of the ball, right? Dimensions. Dimensions / then shape of ball. And there we go, right? So if you get a question tomorrow, it's just going to be 1 mark, right? But if it does ask for a limitation of the model, that is what you're looking for. Either the spin of the ball, the dimension shape of the ball, or something about not following the path perfectly. Any of those there would be absolutely fine, right? So there we go then. That is the solution to question 6, which is not my favorite question. I hate projectiles. I hate mechanics in general. Can we do a poll? Where do I put a poll? Can you do a poll? I would ask what everyone's favorite is, whether it's stats or mechanics, but I can't do that. But never mind. You can put it in the chat. Which do you prefer, stats or mechanics? We'll kind of guess by what everyone puts, basically. And I'm going to move on to question 7 in the meantime. Someone's put Wheel of Stats, gang. Yeah, I prefer stats as well. Definitely over mechanics. It kind of goes pure stats and mechanics. Someone's put, it's going to ask what's the spin in Perth while the sun's heat is 4 degrees Celsius in England. Bruh. Yes, that accepts the large data set. It seems pretty even, to be fair. I think probably, to be fair, though, actually more mechanics. I think probably the big thing there is a lot more students do A-level physics, which obviously if you do A-level physics, the mechanics becomes pretty straightforward. So yeah, mechanics better, but stats is easier. Nah, stats is horrible. Mechanics is bing chilling. Yeah, it is what it is. Anyway, let's move on to questions. I'm just kind of waffling here. We do like the John Cena meme. Bing chilling. Anyway, I'm getting distracted. George throws a ball at a target 15 times. Each time George throws the ball, the probability of the ball hitting the target is 0.48. So the random variable x here represents the number of times George hits the target in 15 throws. 2 probabilities to find here. Pretty straightforward. Let's have a go then. So this is question 7, by the way. So part A then. This is split into 2 different parts here. Part 1 and part 2. We'll start with part 1, right? So let's continue from here. So I want to find, how old is this guy, bro? Put in the chat, how old do you actually think I am? I am not sitting the A-levels, though. I'm definitely not sitting the A-levels, but you can put in the chat. You can have a guess. Have a guess. Anyway, I'm going to carry on while we're going. But if people want to guess, then we'll go from there. But anyway, to begin with here, let's define the distribution. Someone's put, you can't be older than 21, bro. I'm definitely older than 21. 24, 28. I'm a little bit older. Someone's put 33. I'm younger than 33. Nobody's put it yet. Someone's put bro was 89, well in the mask of 18. Nobody's still put the answer yet. I'm not 22, I'm not 25, I'm not 27. Late 20s, yes. I am late 20s. Nah, nobody's still got the answer. I'm going to continue though. So anyway, let me just define the distribution here. So X follows a binomial distribution. There we go. Someone's put it 29. I am 29. There we go. So I'm just before 30. I'm about to reach UNC status. So I need N and P here. So N is your sample size, which is 15 for this question. So that's 15. You're 29 on a good day. Yeah, that's true. So 15 for the sample size. The probability of success here is 0.48, right? That's what we're told here. So 0.48 there, like so. Bro is 6'7". Not quite. So what I now want to find here is these 2 probabilities. So for the first part, then the probability that X is equal to 3. Again, this is just a binomial distribution. Just grab your calculator, right? Bro reached UNC status 29 years ago. Yeah, I guess so when I was born. There we go. So again, we're just going to use our calculator here. Pretty similar to the first question, right? But again, do we use BPD here or BCD? So BPD or BCD. What we're going to use. Someone give us a shout. Yes, perfect. For the first part here, it's going to be BPD again, because it's an exact probability. For the second part, that would be a cumulative distribution. Or it's a cumulative probability, right? So we use BCD. But for part A then, BPD, right? So again, I'll just kind of walk through how to do this using your calculator. So it's going to be BPD. We want a few different things here. So I want N, the sample size, which again is just 15. So N is 15. P, the probability of success, that is 0.48. And then for X here, that is whatever we're looking for, which is 3 here, right? So X is 3. Enter those, put put them into your calculator and press enter. And hopefully we do get the same here because I got the first one actually wrong, which was embarrassing. But hopefully we all get the same here. Do we get 0.0197? Did everybody else get the same, or have I made a stupid mistake again? I'm going to wait until somebody says that they got the same. Yes, 0.0197. Perfect. Yes, good stuff. Okay. Someone's put 0.0254. Yeah, someone else put 0.0196 or 7. So I think 0.0197 is correct. So yeah, so people are putting they got that. So I'm going to roll with that for now because it seems like most people got the same. Let's continue then. So for the second one here, this is the probability then that x is greater than or equal to 5. So again, you can't just throw this into your calculator as it is, right? What I want to do then is do 1 minus the probability of everything less than that, right? So 1 minus the probability then x is less than or equal to 4. Like so, okay? So 1 minus this probability here, again, just grab your calculator. N is 15, P is 0.48. For this one here, for part 2, that is B, C, D. It's cumulative, right? So just be careful for that. And X here is 4. So what I get here then is 1 minus, so it's going to be 0.0799. 0.0799. Again, just evaluate this here in your calculator, and hopefully everyone agrees here that we get 0.920. But again, I'm going to wait for everyone else to kind of confirm that in the chat. You guys are the math scheme here, basically. If you all get the same, then that's fine. If not, something's gone slightly wrong. But I'll wait for now before I continue. All right, part B underneath for now. Yes, 0.920, so on and so on. 0.9201. Yes, perfect. Good stuff. We've all got the same, so that is promising. Right, so we'll continue then with part B. Now for part B then, we're told that George now throws the ball at the target 250 times. So George needs a new hobby. So for part B then, it just says use a normal approximation to calculate the probability that he will hit the target more than 110 times. Right, so clearly, because we're told it in the question, right, we do need a normal approximation. Don't forget, and I've already seen somebody mention it here, with a normal approximation, we do need what we call a continuity correction, which sometimes students do overcomplicate. It's not too bad, and I'll kind of explain that in just a moment. So, to begin with here, I need the parameters then of our normal distribution here. So, what I'm going to put here then is I'll just define this as a new random variable. I'll call this y here. So we'll just call it y. So y then will follow a normal distribution. Someone's put mu is NP. Yes, exactly. And the standard deviation is the root of n minus 1 times NP. Yes, exactly. Perfect. So n here, that's our normal distribution because we're using a normal approximation. Someone's put when do you use continuity correction and when do you not? So we use a continuity correction here when we are using a normal approximation. If you're ever using a normal approximation, we always use a continuity correction. If you're just doing a question on the normal distribution, you don't need a continuity correction. We only use a continuity correction then for the normal approximation. Okay. So continuity correction. I can't spell, so I'm just going to abbreviate this to C.C. Okay. Meaning continuity correction. So the mean here, as people have already pointed out then, is MP. And then for the variance here, it's going to be MP times 1 minus P, like so. Okay. So let's just do this underneath here. So Y will be a normal distribution here. MP then, so that's going to be 250 times 0.48. I'll just do it up here just so it's clear what I'm doing. So mu is 250 times 0.48. which gives us 120, like so. And then for the variance here, that is going to be, so it's going to be MP, which is 120. And that times it by 1 minus P. So P here is 0.48, so it's going to be 0.52. And that gives us 62.4. Like so, okay? So, I'm not sure what's going on in the chat. People are waffling about Einstein. Einstein is no laughing matter, gang. Yeah, Epstein. Oh, I thought it was Einstein Epstein. Okay. Yeah, I don't really know what's going on there. I thought it was Einstein. Never mind. Okay, I won't go into that topic. So let's just continue. So what have I got here? MP then is 120. And then the variance here is 62.4. Yeah, I thought it was Einstein. I won't lie. I completely misread that. Yeah, I'm not really sure what's going on in the chat. I'm just going to ignore that. Yeah, chat's doing anything but maths. Yeah. Anyway, so for the variance here then, that is 62.4. 62.4. There we go. Right, so all we're going to do here is just use our calculator again, right? In this case here, this is NCD. Quick point here, don't ever use NPD, right? So don't use NPD. Don't use NPD, okay? So we use NCD here. NCD here. And we just throw this into our calculator, right? So mu here is 120. For the standard deviation, don't forget, this is the square root then of 62.4. So just be careful for that. It's not 62.4. It's the square root of that. So, and then you want the lower and the upper. I'm just kind of reading the chat as we go here. So what am I going to get here then? So for the lower and the upper, well, that depends on what you want to find, right? So for the probability here, I want here the probability then that y is greater than 110. But first, I do need to apply the continuity correction. So y is greater than 110, like so. But we do need the continuity correction here. So because we want y to be greater than 110 here, that means that we don't want the 110. So in that case, then what I want here is the probability that y is strictly greater than 110.5. So we either just add then 0.5 or we subtract 0.5, right? So that's what we're doing there. Someone's asked, where does the 0.52 come from? The 0.52 then comes from the this formula here, so 1 minus p. If p is 0.48, 1 minus 0.48 is 0.52, right? So input this into your calculator. The lower here is going to be 110.5. The upper will be an arbitrarily large value. So just put a load of 9s in there. Something like that is absolutely fine. Just something arbitrarily large. Press enter. And what I get here then is 0.885, which I can see somebody else has put. Yes, perfect. 0.885 there. Perfect. And there we go then. Perfect. Yes, I've got the same as you. 0.885 there. Spot on. Perfect. Okay, so there we go then. That is the solution to question 7. I'm going to try and speed this up a little bit. I didn't want it to go too long. Someone's put, how do you know whether to add or subtract 0.5? It depends on what you want, right? Because I want here y to be strictly greater than 110, then I know that I don't want the 110, so I go 0.5 bigger. It always depends on the context of what you're looking for in terms of the probability. So just be careful for that, right? As I said before, because we don't want to include the 110, then we write that as 110.5, okay? So that's a solution to question 7. Question 8 here is a pretty straightforward question, right? What we have here is a speed time graph. And this was from a pretty recent paper as well. Was it 23 off the top of my head? Someone's put, can you do moments? I don't have any moments questions for this stream, but I might include one in the later stream today. So hop to that and you'll find out. Anyway, let's just continue here. So this question, like I said, hopefully pretty straightforward for pretty much everyone. I'm not going to read through all of this waffle here. This is just a speed time graph, right? It just gives you a bit of information. For the first part then, I want to find the acceleration of the athlete during the first 4 seconds of the race, stating the units of your answer. Yes, this question is pretty chill. So what I want then for the acceleration of the athlete during the first 4 seconds is the gradient of this line segment here, right? So I want the gradient of this line here. So just consider this over these 2 points, right? So that point there is 4, 10, and then 0, 0 here, like so. So M here, that's going to be 10 minus 0 over 4 minus 0, giving us 10 over 4. That's 10 over 4, and that would be 5 over 2. So I get 5 over 2 there. Don't forget the units as well, right? So what I'll say here then is therefore the acceleration here is 5 over 2. So 5 over 2, that is a 5, but it looks pretty shocking. I'll just quickly redo it, just so I don't confuse anyone. So 5 over 2 meters per second squared there, okay? And there we go then, so that's 2 marks in the bag, hopefully. Nice and easy. Now for part B then, it just says, find the distance covered by the athlete during the first 18 seconds of the race. Now don't forget then, if we're looking for distance covered here, what we're looking for then is the area under the graph, right, for that given period of time. So if it's the first 18 seconds of the race here, I want all of this area here. So this area here under the graph, right? So there's 2 ways to really go about this here. You could split this up into 2 separate shapes. So you've got a right angle triangle here. You'd have this rectangle here. That's fine. Or you could just find the area of the trapezium, whichever you find easier. What I will do is go back to my original pen color. So I'll do it as a triangle and the rectangle here, but it doesn't really matter which one you want to do. So the area of the triangle then, base times height divided by 2. So 4 times 10 divided by 2, that's going to be 20. So the triangle has an area of, that's supposed to be a right angle triangle, by the way, 20 units squared. I'm just going to put 20 there. And then the rectangle here, I'm just waffling here. That's going to be a base of 14 times by a height of 10, gives us an area of 140. So to finish with then, just add those together. Yes, I can see people putting the answer of 160. Someone's put the answer as 140. I'm not sure if that's bait. It's 140. I asked ChatGPT. Yeah, ChatGPT is wrong. It is 160. So therefore then, the distance covered is 160. Okay. We're working in meters here. Yes, it's a 200 meter race. That's 160 meters there. Covered. Okay. There we go. So that is the solution to part B. Again, pretty straightforward. And then finally for part C here, we want to find the value of U. So what is U here? So the athlete then decelerates at a constant rate from t equals 18 to t equals 24, crossing the finish line with a speed of U meters per second. Okay, as we can see here on the graph. So there's a couple of different ways that you can do this here, but I think the easiest way then is to consider the remaining distance here then from 18 to 24. So that, I'll do it in green here, that's going to be 40 meters, right? If this bit here is 160 meters and it's a 200 meter race, then that must be 40 meters, right? So that there is 40 meters remaining. And what I can do here then is just find the area of the trapezium, right? So area of the trapezium here, area of the trapezium. So area of the trapezium here. So that's going to be then a half times, so it's going to be 10 plus u is equal to 40, right? Which is the area here. So I've got half times 10 plus u is equal to 40. So it's up to you. You can either just expand here or just divide both sides by a half. It's completely up to you. Yeah, it don't really matter. I'm just going to do then, just expand it out here. Oh, sorry, I forgot to times by 6. There we go. I was going to say something's not working here. I forgot to times it by 6. Sorry. I was going to say, what is going on, fam? There we go. I forgot to times it by 6. There we go. And that's equal to 40. There we go. I was going to say, what is going on? So yeah, 6 times a half is 3. So I've got 3 bracket 10 plus u. I am not locked in today. Definitely not locked in. It's a good job I'm not doing the exam tomorrow. And that's equal to 40. And then, so in case you're wondering where the 6 comes from, it's this, right? 1824 is 6, just in case anybody's wondering where that came from. And then, just expand this out here, or just divide 3 by 3. It really doesn't matter. So 30 plus 3u is equal to 40. Subtract 30 from both sides. 3u is equal to 10. And then divide both sides. I really can't speak today. U is equal to 10 over 3. I am cooked. So that's u. So 10 over 3 meters per second. Okay. There we go. So 10 over 3 meters per second there. Yeah, that was a pretty straightforward question. Don't forget the times in by 6 there, which I nearly forgot. So yeah, hopefully that wasn't too bad, right? So that's question 8. Like I said, quite a nice, easy question just to work through there for mechanics. So question 9 then, the penultimate question here. Let's just continue. A little bit of probability here. I haven't included too much probability, right? So we'll quickly work through this one. So for the first part here then, I'm not going to read all this waffle. Part A, it just says then, complete the tree diagram in terms of P where necessary. So we can just kind of like speed through this, right? This is going to be 1 minus P. It's the complement, this here. So if that's 1 over 8, that's 7 over 8. Again, it's the complement. And if this is 1 over 10, and that is 9 over 10. If you want to, you can give it as a decimal. That's absolutely fine, but I'm going to keep it as fractions here. So that's the tree diagram complete. Nothing too bad there. For part B then, I'll just write here tree diagram. So tree diagram. So for part B then, it says the probability that a student is left-handed is 0.11. For part B then, find the value of P. So for a student to be left-handed, I've got 2 different options here, and I'll highlight these in different colors. So they can be in year 12 and left-handed, or they can be in year 13. They can be in year 13 here, and then also left-handed as well. Okay, so we know that this probability here is 0.11. So I'm going to do P times 1 over 8. I've got P times 1 over 8 plus then this here. So this product is 1 minus P and 1 over 10. Yeah. So 1 minus P times 1 over 10. And this here then is equal to 0.11. Okay. So let's just simplify this here. I get 1 over 8P, 1 over 8P there. This here, I'm going to get 1 over 10 and minus 1 over 10P. 1 over 10 and minus 1 over 10P, like so. And that is equal to 0.11. Yeah, somebody's already shouting the answer right here. P equals 0.4. So just simplify the left-hand side here and subtract 1 over 10 from both sides, right? So what we get here is 0.025P. Did I get that? Yeah, 0.025P is equal to 0.01 there. And therefore then P here is equal to 0.4 or 2/5. All right, it's 2/5 here, just to make the calculations a little bit easier. There we go, bosh, okay? So that's a solution to part B. Now for part C then, So for part C here, it says find the probability that a student selected at random is in year 12 and left-handed. So what I want here is the intersection then of year 12, year 12 intersection left-handed, right? Which, if we just refer to our probability tree here, then as we can see, it's going to be P times 1 over 8, right? So pretty straightforward then. P here is 2 over 5, so it's going to be 2 over 5 times then 1 over 8 here. 1 over 8, like so. That's going to give me 2 over 40, and 2 over 40 then is the same as 1 over 20. There we go. Perfect. Okay. Hopefully not too bad. And then for part D, probably the most challenging part of the question, but even then, I don't think this is too bad. So for part D here, it says, given that a student is right-handed, find the probability that the student is in year 12. So hopefully it's obvious then that this is conditional probability here for part D. So what we want here is the probability then that the student is in year 12, given that they are right-handed, okay? So what would this be here? So for conditional probability, don't forget then, that's going to be the intersection of these here. So it's the probability of year 12 intersection right-handed. So the probability here then of year 12 intersection right-handed. And that is all over then the probability of being right-handed. Okay. So for year 12 and right-handed, that's going to be year 12 and then right-handed. So that's P times 7 over 8. So P is 2 over 5. So 2 over 5 times then 7 over 8. And that is all over the probability of R. So I'm going to throw it to you guys. What is the probability of R here? Because you're not told it, definitively in the question, so you kind of have to pull that out of the question. So what is that? It shouldn't be too challenging, but just a double check here. What do people get? Someone's put you low-key sound like Tom Aspinall. I would actually knock Tom Aspinall out, right? It's funny you say that as well. Someone put that last year, that I sound like Tom Aspinall. But yeah, funny coincidence. I am not Tom Aspinall, though. So, nobody put the probability of being right-handed, I don't think. So it's just going to be 1 minus then this here, right? The probability of being left-handed is 0.11. Then that's going to be 0.89. 0.89 there, right? Like so. Throw that into your calculator. And somebody put it before, right? 35 over 89. Will Manning. Yes, you are correct. 35 over 89 there. Spot on. Perfect. Yes, perfect. 0.89 is right-handed. No. Yeah, I think there might be a little bit of a delay. So anyone who's put 0.89, yes, I agree with you there. So yeah, perfect. That's question 9. Complete, lovely, jubbly. We're pretty much there now on the final question, and we've just hit 2 hours, so we're pretty much there now. Let's just quickly finish then with this question here. Question 10. Why is my pen doing that? We don't want that. So question 10 then. The final mechanics question here. So it says a particle of mass mkg is sliding down a rough plane that is angled at theta to the horizontal. The coefficient of friction between the particle and the plane is mu. Show that the acceleration of the particle is independent of its mass. So to finish with here then, let's just draw a diagram, because as we can see, we don't have a diagram, right? So we've got the flat horizontal surface here, like so. It should just be a straight line, but it'll do. And then we've got the inclined plane, right? So something like this, okay? The angle here, as we're told then, is theta. So that angle is theta. So the particle is going to be somewhere up the plane here. What I will actually do, just so I've got a little bit more room for my forces, I'm going to put the angle just underneath here. Someone's put, do a 24-hour marathon. Unfortunately, lads, I can't do that. So I wish I could, but yeah, I can't do 24 hours. That is next level. So feet here. I'm going to put that underneath them. So the particle's going to be somewhere towards the top here. Like so. Okay. Something like that. Now, this particle is sliding down the plane. Yes, a matheton. There we go. So anyway, let's just continue. So what forces do I need to include here? I've got the normal reaction between the particle and the inclined plane, right? So that's going to go up like so. We'll label that as R. We've got the weight force acting vertically downwards, like so. And the particle here has a mass of mkg, so the weight force would be mg. So that's mg, like so. What I'm also going to do here is split this force into components. So components here. What am I going to get here? I've got my two components here. Yes, diagrams are the meaning of life. They are for mechanics. For stats, you don't really ever need a diagram, but for mechanics, yeah. The diagram will just make the question a lot easier. So this component here, put it in chat then. What's this component going to be here? So this vertical component here, what would that be? Yes, perfect. Someone's put mg cos theta. Yes, I can see a few people mention it now. Perfect. So cos theta times mg cos theta. Yes, exactly. Gang. So mg cos theta. Like so. And then for the horizontal component here, that's going to be mg sine theta, right? So mg sine theta. There we go. Now, let's resolve forces here. Oops, I'm knocking my microphone. So, I'll start by resolving, taking up here. So this would be perpendicular to the plane, really, right? Perpendicular to the plane. Resolve perpendicular to the plane here, like so. So forces acting up will be equal to forces acting down. Can we ladder on the stream later? And what time is it going to be? It'll probably be 5:30. I'm going to confirm it a little bit later on. But yeah, I will kind of add a post out after this. But yeah, 5:30. Keep an eye out for that. So forces acting up then, it's just going to be R, right? And there's no vertical acceleration here. So forces acting up will be equal to forces acting down. So yes, somebody's already put it here. R is equal to mg cos theta. Mg cos theta, like so. And now, if we resolve parallel to the plane here, we'll take down as positive then. There is acceleration to account for here because it slides down a rough plane. So I need to add that. Oh, I also forgot friction as well. So that is a meters per second squared. And let's not forget friction here. So the particle moves down the plane. So friction acts in the opposite direction. So that's F, which is mu r. Okay. So what am I going to get here then? So taking down the plane as positive here, I'm going to get mg sine theta. So I'm going to get mg sine theta. So mg sine feta cheese is sorry, it's not equal to. I also need to account for friction here because friction acts in the opposite direction. So I've got mg sine theta minus mu r. So minus mu r. So that's friction, right, which acts in the opposite direction here. There's no more horizontal forces here, so that's all well and good. But using Newton's second law here, big Newt, somebody mentioned before then, this is equal to the mass times the acceleration. Why are my pens doing that? I don't know. Try again. I think my pen's had enough now at this point here. So that's the mass times the acceleration, which we don't know either of those, right? So we just write it as ma. Okay. So what can we do here? What I can do then is replace r here with mg cos theta. So what I get then is mg sine theta minus mu r. So that's minus mu then times r, which is mg cos theta. Mg cos theta, like so, is equal to ma. So what can we do here then? So I can just divide through by m here, right? So m, we can just divide through by that, like so. I get g sine theta minus mu cos theta, sorry, minus mu g cos theta, there we go. Careful for that. Minus mu g cos theta is equal to 8, right? So to finish with here, why does this show then that the acceleration of the particle is independent of its mass? What have we kind of shown here, basically? What I'll also do as well is I'll just pull out the g as a factor. You don't have to do that, but I think it looks a little bit neater. So g bracket sine theta minus cos theta. And that is equal to a. Okay. I forgot the mu there. Oh, dear, dear, dear. Let's try again. So minus mu cos theta. There we go. So yes, exactly right, because m is not in the equation. M isn't present. So m is gone, right? It's disappeared. So therefore then, m does not appear. So as m does not appear. M does not appear. Then therefore what this shows here is the acceleration of the particle. Acceleration of the particle. Acceleration of the particle is independent of its mass. Okay. And there we go. So just to give it a little bit of conclusion, that M got blown up by a bazooka. Yeah, pretty much. We destroyed it. There we go. So that is the solution then to the final question here, question 10. If you're still here watching at this point, I just wanted to say thank you so much for watching. If you haven't already, please do have a go at our predicted paper 3 that we released yesterday. You know, that was it yesterday I released it or the day before? I can't remember. Probably yesterday. I've done too much maths recently. My brain is just fried. But yeah, that was all 10 questions there. Paper 3 I released either yesterday or the day before. If you haven't already, give it a quick go. There's also another 3 predicted papers on our YouTube channel. So again, if you've never had a go at those, give them a go. It's just extra practice, right? I am not saying the paper will be exactly like those papers, because there's always somebody who comes back after the paper and goes, you got it all incorrect. Well, you know, it is just a prediction. I'm not a psychic. I wish I was, but yeah. So just so you're aware, it is just a prediction. Please do use plenty of extra revision resources as part of your revision. So yeah, so there we go, right? If I don't see you later on or in any of our predicted paper videos, then best of luck for tomorrow. Someone's put, where is the paper? The paper is on our website, asianmaths.co.uk. It is for our members, so I can't give it away for free because we had to create the papers ourselves. So they're not free. They're available to our members on our website. If you're not a member, then we're giving away 50% off today using the code revision. So revision. And that is for the 4 papers there for paper 3. But as I said, they are all available on YouTube if you want to just have a go at it on the screen. But if you want the actual PDF, then yes, they're available for our members on our website. That's for 50% off. 50% off. And that is for £4.50 there. Someone's put, I'll dedicate 1% of my future $1 million business to you. That sounds nice, mate. I like the sound of that. So I'll keep an eye out for you smashing it in the future. Thank Thank you so much for everyone who's watching. I'm just kind of reading the chat before we go here. Somebody's put, leak the paper for tomorrow, bro, please. I don't have the paper, so definitely not doing that, mate. Thank you for all the love hearts. How do I put something? I put a smiley face. Did that do anything? I don't know. Oh, I think so. There we go. Time to invest into AJ Maths, adding him to my stocks portfolio. Yes, that's a good idea. Someone's put you're going to be seasonally unemployed now. Exactly right. I'm going to be part of the unemployment statistics. So yeah, there we go. Yeah, thank you so much for everyone who's watched though. As I said, catch us in the later stream. Check out the predicted papers, and best of luck for paper 3 tomorrow if I don't see you in either the later stream or any of our predicted papers videos. But yes, I'm going to close the stream at this point here. Best of luck, guys, and thank you for watching.